Life's online, so's mine. By fall we'll be okay. It's like your family is always near. When we haven't had our sports in over a month, it seems like a year. I'll be there for you to improve your last score. I'll be there for you like I've been there before. I'll be there for you 'cause you're there for me too.
Happy Monday, everybody. And we only have one more Monday left in this school year. And so I noticed that 9 of you are sending me and emailing me assignments and doing your work after 10 p.m. last night. So for you, Monday mornings must be rather rough. Or maybe it's rather easy to roll out of bed, but then picking yourself up off the floor is probably another thing. But at least look on the bright side. At least Mondays only happen once a week. You know that Sunday and Monday got in a fight. And you know who won? Sunday. Why? Because Monday is a weekday. And so, make sure you take attendance. This is Monday, May 11th, and this is e-learning. In store for this week, this is Math Counts week, and because if you're involved with that, Math Counts, since our state finals were canceled and there was no opportunity to for the national competition, Math Counts has provided a lot of activities because this would normally be the National Math Counts week. And so if you click on this link, you're going to see a lot of opportunities for this week. And so today, they all occur like they call it pie time at 3:14 p.m. And so that's after our e-learning day from 9 to 3. And so Monday, there's some math video challenges if you want to watch those. But Tuesday, they're going to create kind of a countdown round finals from a previous one, and so you might want to check that out. Wednesday, though, is the big day because we're going to do the open Math Count state competition. It'll be unofficial, but there will be prizes, and so that'll be exciting. You have to register, so click on that, register now, and look into that. If you need my help on anything, let me know. And so these are things you can do, and so that's Wednesday. Wednesday's the big day. Thursday, I think you can still finish up things till Thursday afternoon, and then they're going to go over answers. And so Wednesday and Thursday are great days, and then Friday they have some activity in the world's largest countdown round. And so really Monday and Tuesday, but I'll try to remind you of these things as the week goes on for Wednesday, Thursday, and Friday. Okay? And so for this week, we do have new warm-ups. A couple of you are falling behind, not very many of you, but there's 3 new ones. You need to click on those and the logic problems. And the logic problem hints for this week. The first couple. Find 3 numbers, just 3 numbers, that add up to 201. Which 3 of these? Boom, boom, boom. Those 3? Which 3 add up to 201? I sure hope I didn't click on the right 3. I better delete it quick. Oh, you could rewind and then figure out what the answer was. What 3 numbers add up to 222? Just pick 3 sections. Maybe it's this section, and this section, and this one. Well, I know it's not these 3 because this ends in a 0. So, and just highlight them, and you'll get it. Okay? So a couple quick ones there. Then over here, we have plug in the numbers 1 to 9. So you're using each of them once. And so 1, 2, 3, 4, 5, 6, 7, 8, 9. Just use each number once and only once. And we're ignoring order of operations. So for example, if we're going to add 2 numbers and then divide by 2, you're going to, hey, I'm trying to teach. And add 2 numbers and then divide by 2, you're going to add first. And so if you want these to add up to twice this. So if this is a 3, you want these to add up to 6. If this is a 4, you'd want them to add up to 8. If this is a 5, you'd want to add these up to 10. Okay? So there's lots of possibilities, and then you got to make these work down. How do you get to 15? And things like that. Okay? Then down here, you're counting total triangles. What I would do is count them one at a time. 1, 2, 3, 4, 5, 6. There's 6 that are just 1. And then write that somewhere. Now, how if I included 2 at a time? Or 2 sections? There's 1 there. There's 1 there. Here's 2 sections at a time. And then count them 2 at a time. Then you would count them 3 at a time. How many of those? Then you'd count them 4 at a time. And here's a 4 at a time. And then you got this big one. You got a big one. You know, you got quite a few. You count those. Same thing with rectangles. Squares are rectangles, so you count those too. And I would count the 1 at a times. How many 1s are there? And then count them 2 at a time. And then count how many of those. And count the 3 at a times and 4 at a times. And then come up with an organized way of counting those. Now this bottom part here, we did one like this the other week. I think it was 2 weeks ago. You're plugging the numbers 1 to 20 in exactly once, so you might want to write them out. A 1, a 2, a 3, a 4. And 2, it's just factor pairs. 2 numbers multiply together give you 20. But this problem's different because it has a diagonal. And on that diagonal, I didn't say how many pairs. It just says, so each row and column contain 2 numbers. Didn't say anything about the diagonal. Well, I don't want you to be confused since I'm not there with you. The diagonal only has 1 number, and it's a 20. And so where would this 20 go in order for this all to work? Well, look down here. Which one of these are multiples of 20? Well, there's 2 of them. And so it's either going to go in this column or it's going to go in this column. Ryan, the 240? Yes, you'd be correct. I'm telling you, this is where the 20 goes. And there's only 1 number, so all these are going to be empty. Okay? And that's my hint. And then the other hints you can use are from before. Okay? When we gave you hints on how to do this before. Okay? So think of the numbers like 19. Go 19 first, look for 19, look for 17, look for 13, look for 11, look for your primes that are higher. Okay? And if you can locate those, then everything else should fall into place. Okay? And then for the last one, move me out of here. For the last one, remove 3 matches so that each equation is correct. And so it doesn't matter, you don't have to write the letters of the matches. I was going to do that, but... And good luck trying to get the other 2. And so, if we look at this last one, 8 times 9 plus 76, does it equal 90 plus 36? No, it doesn't. Well, I got to remove 3 matches. Well, if I remove this one, this would make a 0. 0 times 9 is 0. And 0 plus 76, 76 trombones that lead the big parade. Could I make the other side equal to 76? Yeah. You would just scribble out this one, and you would scribble out this one. And that would be 40 plus 36. And see, you showed me what 3 matches you scribbled out, and you can even show me that you get 76 on both sides. And so there, that one's done. Now you got 2 more. Okay? And you just have to eliminate 3. There's no tricks. It's just eliminate them so you can figure out the answer. Okay? And so, logic problems, many of you have been doing them. I hope you've been enjoying them. And that's a way to raise your grade. And so if your homework, you're getting 10s, 9s, you get an 8 or a 7. It's like, oh, my grade's not good. Just turn in some logic problems. Boom, you're good to go. And so make sure you get those in. And we only have a couple more weeks of these. Okay? So let's go to the notes and see what's in store. Geometry today. And as we're going through this analytical geometry, a lot of it is just connecting the algebra to the geometry. And so today we're going to connect the equations of a line. And so I only assigned tonight page 555, 34 to 39. And I give you a handout with a graph on each one. You might not totally need the graph, but I would graph it. And so, and the last ones all have to do with the same problem. And then it ends with Euler's line. It's like, oh no, what are you doing? And so there's only a handful of questions, but they're kind of hard. And so we'll get to those. But before we do that, we're going to print off the notes and we're going to refresh your minds about equations of a line. And so this is notes 125. And so you make sure you write that, notes 125. But we want to review the different equations of a line. So give me one equation of a line. Jacob? Yeah, y equals mx plus b. The first one you were ever taught, the slope-intercept form of a line. And hopefully you can write it a lot neater than me. What would be another equation of a line? What would it be? Vadim? Yeah, standard form. Now that one's not that useful because that's the one we clean up. Remember, it was ax plus by equals c. And if you got it in standard form, that's your m is always equal to, what was that, Kaya? Yeah, the opposite of a over b. And the y-intercept was always what, Grant? Yeah, c over b. And those were shortcuts that we talked about in pre-algebra and algebra 1. And then another very useful form of a line that we would use today is the point slope form of a line. And what would that be? Charlie? You don't remember? Charlie, I'll help you out. Y minus y sub, oh yeah. Charlie, tell me the rest. Y minus y sub 1, good job, equals m times the quantity of x minus x sub 1. Now that is called the point slope form of a line. And you use that if you want to find an equation, if you know the slope and you know a point, x1 and y1. And that form of a line some people don't ever teach because it's not really a new form. Remember, it comes from just the slope of a line is the difference of the y's, the change in the y's, over the change in the x's. And if you cross multiply and stuff, you'll get the point slope form of a line. So the change in the y's over the change in the x's. So if I said I want to find the equation of the line 3, 3, and 5, 7, well, here's 3, 3, and then here's 5, 7. And if I want to find the equation of this line, I've been given 2 points. Well, if you draw a picture, you can figure out rather quickly what the slope of this line is. But if you didn't have a picture, you would do 7 minus 3 on top, because those are your y coordinates. And then 5 minus 3 on the bottom, because those are your x coordinates. And then obviously you're rising 4 and you're running 2. Well, you could have got that from this picture. Here's a dot. I rise 4 and I run 2. Where you running to? And so that's really like having a slope of 2. And so also if you draw the picture, you wouldn't need a bunch of algebra because you could say, well, here's my dots. Well, then what's my b? Well, your b is -3. And you could simply say, well, the equation of this line is y equals 2x minus 3. And you get it from the graph. But if you didn't have a graph in algebra, we talked about, okay, here's your slope. And you could pick a point like 3, 3, or you could pick 5, 7. It really wouldn't matter. And if I plugged into the point slope form of the line, I would have y minus, I'll use the 5, 7. Y minus 7 equals 2 times the quantity of x minus 5. Well, then you'd get y minus 7 equals 2x minus 10. And what do you get when you add 7 to both sides? Oh, lo and behold, we get y equals 2x minus 3. We get the same thing we got if we looked at the graph. And so that would be the equation of the line. So connecting our algebra to geometry called analytical geometry. Okay? So let's take a look at this next example. We're going to use algebra to find out where these two graphs cross. Well, a couple things is we wouldn't have to use algebra even though it said to. We could graph this line. And then we could graph this line. Well, wait, that's not a line. Wait, what is that, Aline? That's a circle with radius 5 that's centered at the origin. And so if I graph that, here's the center, and we go up 5 and over 5. And if we did a 3, 4, 5, that means, or a 4, 3, 5, that means these would also be radius 5 because of the 3, 4, 5 triangle. And I would have a circle that looks like this, which I'm going to freehand. Now, Urbanski, when you're drawing something round, you don't use a straight edge. Remember the ellipse? And so just try to round it as best you can, but it needs to look rounded. But you should have a compass for this. But I don't have a compass on this thing. And so there's your circle. Well, that's a circle radius 5. Then we want to know, where does this line cross? Well, this line, if we use the shortcut, because it's in standard form, the opposite of A over B, that would be -1 over -2, which would be a half. And then the y-intercept, which is just C over B, would be -5 over -2, which would be 5/2, which is 2.5. Now, do you really want to start at 2.5 and then go up 1 over 2? And then down here. You know, that's kind of hard to do, to see where these things cross. But you could. And we could graph this, and we could try to use our knowledge of geometry in a picture to figure out where these points cross. But if we were going to use algebra, remember, we could solve systems of equations, and one technique would be to, what, Sidel? Yeah, just solve for x. And this would be, let's change colors here. This equation would just be x equals, if we move the 2y over, it'd be 2y, the -2y would become positive, that'd be 2y minus 5. And then we could take this and plug it in. So we would have 2y minus 5 quantity squared plus y squared equals 25. And then what would that FOIL into? Well, I guess we have to ask a foiling champion, Isaiah. What would this FOIL into? 4y squared minus 20y plus 25. And then we have the plus y squared, and we have equals 25. Well, if we combine like terms, you'd have 5y squared minus 20y. And if you subtracted 25 from both sides, these would just cancel, and you'd equal 0. Well, the thing is, you don't want to divide by 5y, because you'll lose an answer. You want to factor. You could divide by 5, but remember, don't divide by a letter. When you do, you might lose a solution that you need. And so we factor this. Remember those days? And so y, there's 2 solutions. And so if we can draw braces with a mouse, what does y equal? What would it be, Grant? Yes, 0 and 4. And so I have 2 answers. One answer has a y coordinate of 0. One answer has a y coordinate of 4. And so if we look at this, do these 2 points, does one answer have a y coordinate of 4? Does one answer have a y coordinate of 0? Well, yeah. And so this point is 3, 4. Well, how would you get to 3 if you didn't have a picture? Take this 4 and plug it in. Plug it in, plug it in. But see, if you plugged it into this one, you would get a solution down here that you don't want. So you might get 3, -4. Or you would get this one here. You would get -3, 4. And see, that doesn't intersect the line. So you got to be careful which one you're plugging it into. You don't want -3, 4. You wanted 3, 4. And then plug it into the line one, plug 0 in, and you would get -5. This one is a solution. It's right there. This one is the solution. It's right there. So we used algebra to find the solutions, but we also used a little geometry to make sure we didn't end up at one of these other points where they don't cross. Okay? And so one last example, that'll be an easier one compared to what our homework is. And it says, line L is tangent to the circle of 0.34. Find the radius of the circle. Well, what would the radius be? Taryn? Yes, 5. How'd you know that? Because you gave me a big Pythagorean triple quiz, and that's like the easiest one. 3, 4, 5. So our radius is 5. What's the equation of the circle? Well, Aline already told us in the last problem. X squared plus y squared equals 5 squared. So x squared plus y squared equals 25. Now find the slope of line L. Well, what's true about this segment and this one, Sarah? Don't get nervous. I know you got this. Yes, they're perpendicular. So the slopes are going to be what, Kirsten? Yes, opposite reciprocals. So if the slope of this segment right here is 4/3, because rise 4, run 3, then Kirsten, what would be the slope of line L? What's the opposite reciprocal? Yes, it'd be -3/4. Now it says, find the equation of line L. Well, what do I know? I know the slope of it. Do I know a point? Do I know this y-intercept up here? Is that 5? No, it's above it. It's not 5. Well, I'd have to use point slope. I have a slope and I have a point. So I use y minus y sub 1 equals m times the quantity x minus x sub 1. And so if I have a point, I'm going to use the point 3, 4. So this is going to be a 4. This is going to be a 3. And I can't believe I wrote -3/5. And you're probably going, why did you do that, Mr. Nyson? Is he going to catch the mistake? Yes, I just caught it. This should be -3/4. And so we're going to plug in -3/4 for the slope. And so it's going to be x minus 3. When I distribute this, it's not going to be nice. And this is going to be y minus 4. Well, we could multiply both sides by 4 and just put it in standard form if the book says so. I don't know what it says. Or if you have some fraction skills, you can do y minus 4 equals -3/4 x plus 9/4. Well, 9/4 is 2 1/4. And then when you add 4 to 2 1/4, you would get, Carson, yeah, you just get 6 1/4. So 2 1/4 plus 4 is 6 1/4. And normally we don't like mixed numbers, so you didn't have to. But if we're plotting a y-intercept, does it look like this crosses at 6 1/4? Yeah, I think so. And so that's fine. If it says put in standard form, just keep this 25/4, multiply everything by 4, and make it ax plus by equals c. Okay? And so when we look at these last problems, I give you a graph for everything. 34, 35, 36, 37, 38, and 39. But the thing is, when we look at these, you want to just really attack the problem and do everything possible. In problem 34, it says, quadrilateral back is a rhombus. 2 of the vertices are 3, 5, and -7, 3. So plot those. Then figure out what's the slope of the diagonal EK. Well, if this is B and C, that means those are opposite vertices. And so if we were going to graph this without me going to the other page, 3, 5, right 3 up 5, and then 7, -3, this is B and C. Well, that means E and K are somewhere over here. They're in between. Okay? And so if BC's slope is this, what is EK's slope? Kirsten? They have to be perpendicular, opposite reciprocals. But then you actually have to figure out what the equation of EK is. Well, in order to do that, you need the slope and you need that point. What's that point? It's the midpoint of those 2 points. So use the picture. Even if you don't know where E and K are, you don't really need that. You just need to know the slope and the point, and use point slope, and you can get that. Okay? For 25, it says, find the center of the circle that passes through 2, 10, 10, 6, and -6, 6. Well, on this, you're going to use the graph I gave you, but 2, 10 is somewhere up here. 10, 6 is going to be over here. -6, 6 is going to be over here. Well, the thing is, how would you find the circle that's going to go through these? Oh, you could be a really good guesser, or you could find the midpoint of these two, which should be nice, and then find the opposite reciprocal and find the equation of that line. Then find the midpoint of these two and find the slope that's the opposite reciprocal and find the equation of that line. And then set the two equations equal to each other and you would find that point. So that is what you do. Now, those are the B questions. We skipped. You're good at algebra. I hear you had a good teacher. And so we just skipped to these hard ones. Now notice, for 36 to 39, they all are the same picture. It has vertices, those three. So for 36A, you're going to use all these. Find the equations of all three lines that contain the medians. So what you're going to do, you're going to find the midpoint. And so we're going to do this. Negative 6, 0. I'll write these down. Negative 6, 0 is Q. 12, 0 is R. And 0, 12 is S. And what you're going to do on 36, you're going to find the medians. Then you're going to find the perpendicular bisectors for 37. Then for 38, you're going to find the altitudes. And these are not going to be that easy. And so if we go back to the graph, here we are. Problem 36. We have 0, 12. 3, 6, 9. Oh, it's off the graph. So it just extended a little bit. Mr. Nyson, why can't you make one that fits on the graph? So we're going to do the best we can. 3, could go by 3s, but you don't want to. 3, 6, 9, 12 is going to be up here. And that's going to be point S. Point R, 3, 6, 9, 10, 11, 12. That's going to be point R. And point Q is right here. Okay? So my triangle that I'm going to graph every single time on all these last ones is not moving that. My triangle's right here. So what you're going to do is, if you want to find the medians, first thing you want to do is find the midpoints. And so if this is 12 plus 6 is 18, that means this is 9. There's the midpoint. And this one, if you're 6, 12, that has a slope of 2. It should have a slope of 2. Does it have a slope of 2? Yes, it should have a slope of 2. So the middle one is right here. There's your midpoint. This one, up 12, down 12, that has a slope of -1. So the midpoint here is there. So you have your midpoints. Now how are you going to find the equations of the lines? Well, the medians, you're going to use 2 points. You're going to use this point and this point. And I want a different color. So for the medians, you're going to, I said I wanted a different color. That's a median. This is a median. And that's a median. And so to find the equation of each line, you're going to use these 2 points. Find the slope of this and use point slope. To find the equation of this line, you're going to use the 2 points and do point slope. Find the equation of this line, you're going to do point slope. Now, for the next problem, when you want to do the perpendicular bisectors, you want to use the point, and you don't want to use 2 points. You want to do point slope. You want to do the opposite reciprocal. You want to do the opposite reciprocal. You want to do the opposite reciprocal. And then that's your centroid. Or no, that's your circumcenter. Perpendicular bisectors give you circumcenters. So you're using point slope, not point to get a slope. Then for the next one, you're going to do the altitude. Well, the altitude does not require the midpoints. It just requires this point with the opposite perpendicular to this. So this equation for, I think it's going to be 38, use the point and then just use the opposite reciprocal. For this one, you're going to use the point and then the slope that's perpendicular to that one. And so you'll use this point with that slope. And then here you'll use what slope is perpendicular to this one? Well, it'd be 1. And you'd use a slope of 1 with that. And then that's your altitudes. And here's your altitudes. They all hit right there. And that is called your orthocenter. And you find that. And we're going through all the problems. And then the very last problem, you're going to try to put it all together. And so on the very last problem, not on algebra, use the slopes to show they're all collinear. And so when you find what you're going to do for 39 is you need to write down the point for the orthocenter, you need to write down the point for the centroid, and you need to write down the point for the circumcenter. And then tell me what's the slope of these 2 points, what's the slope of these 2 points. And they're all going to be the same. And then you hit check, that's done. And then you're going to show me by distance that GH is twice as big as GC. Okay? And so you go through those things. It's a lot. All this we've done before with the medians. Remember, when you find a median of a triangle and you connect them to the middle, remember we always said that this was 1/3 and this was 2/3, or this was 1/3 and this was 2/3, and so you got to show that. Okay? So email me your questions. All of you, have a great day, and you're doing a great job. Don't get stressed out if you have a little trouble with these last ones. Bye-bye.